Lesson 4.4 notes, it is about graphing a function rule. So when it says what is the graph of the function rule y equals negative 2x plus 1, well, we don't really know what the graph looks like yet. In fact, we have a graph, but it's completely blank. So how do we graph something like this onto our graph? Well, step one is to make a table of values. So we're going to make an x and y table. And we don't know exactly where this is going to be, but let's choose some values on the x-axis that make sense. I don't want to choose negative 10 because then wherever negative 10 is, there's going to be a dot somewhere, and that's not going to be on my graph. So I want to choose some that maybe go as far left as negative 5 and as far right as positive 5. So a good place to start would be just to choose a couple of negatives, a 0, and a couple of positives. So I usually tend to choose negative 2, negative 1, 0, 1, and 2 when I'm trying to graph a table, because then I know it'll be a little bit over here and a little bit over here, and it should be somewhere in the middle of our graph. So let's see. What you're going to do is you're going to take this x value, which is negative 2, and you're going to plug it in right there for x. So what is negative 2 times negative 2? Negative 2 times negative 2 is positive 4, plus 1 is positive 5. All right, let's keep going. What is negative 1 now for x? So negative 1 is x. So negative 2 times negative 1 is positive 2, plus 1 is 3. All right, 0 is x. 0 times anything is 0, plus 1, 1. All right, now 1 is x. Negative 2 times 1 is negative 2, plus 1 is negative 1. Always check on your calculator if you're not sure. And then the last one, 2 is x, so negative 2 times positive 2 is negative 4, plus 1 is negative 3. The second thing is you actually graph the ordered pairs. So you may not have known that we were doing this, but we were creating ordered pairs. So these 5 ordered pairs become our coordinates. So the first one is negative 2, comma 5. So at negative 2, the function is at 5. At negative 1, up 3. So negative 1, 3. 0 is 1, so 0 up 1. 1, negative 1, so that's to the right 1 and down 1. And then 2, negative 3 is to the right 2, down 3. So this is our rule. And I'm going to put arrows on both ends because this would continue in both directions. In fact, if I had chosen negative 10 as one of my numbers, it would be something on this line. It would just be way up here. So I just wanted to keep numbers from negative 2 to positive 2 to see where it is on this particular section of the graph. Okay, let's go down to our definitions. A continuous graph is exactly what we did. We know there's arrows on each end because it's going to continue. So the textbooky definition is a graph that includes all points on the line. Okay, I'm going to be more specific here in just a minute, but that is including fractions, decimals, etc. Okay, so what I mean by that, and I'll show you in an example sketch. So we just sketched a graph above that looked kind of like this, with arrows on both ends. So I think we had a couple of points in there that looked maybe like this or something, but a continuous graph means it's actually all of those points in between there too. So all of these little fractional parts, these little decimals, it would be every single point infinitely on this continuous line. So that would be a continuous graph. It is a line and a continuous every point on that line. It doesn't also have to be a straight line. It could be a curved line too. So, but if it's all the way through and it's connected with arrows on both ends, that means all these millions, infinitely many points on that would be a continuous graph. Okay, then we've got a discrete graph. This is a graph that only works a graph that only works for certain points on the line, on the interval. I mean, it's probably going to be in a line, but I'm going to call it, I'm going to call it an interval. And usually, I'm just going to go ahead and add this little bit, usually only whole numbers. Not always, but usually only whole numbers. Okay, so this would be like, we'll do some examples here in a minute, but it would be like if this is my line and you really cannot connect it with a dot. They're just going to be whole numbers. And the reason is if I were trying to raise money by selling bracelets. Let's say I'm going to make some bracelets, and one bracelet would make me this much money, and 2 bracelets would make me this much money, and 3 bracelets would make me this much money. I'm not going to sell a half a bracelet. I'm not going to sell one and have like somewhere in between. So it doesn't make sense to make a continuous line. So only selling 1 bracelet or 2 bracelets or 3 bracelets. So I wouldn't have a continuous line like this. That wouldn't make sense. So discrete is separated out points. Okay, let's look down here at farmers market examples. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make it the price at which he sells. And I also forgot that the W that they're talking about down here represents weight. So just FYI, I'm going to write this down. I don't know if it says that anywhere, but the weight of the cheese is what he's trying to make with the milk to make the cheddar cheese. So what is the function? And then we're going to write a function, we're going to create a table, we're going to graph it, and then we're going to tell whether it would be continuous or discrete. So the function is 1 gallon of milk makes 16 ounces of cheese. So 0 gallons of milk is going to make 0 pounds of cheese, or ounces. Weight is in ounces. 1 is going to make 16 ounces. 2 then would make 32. 3 then would make 48. I'm just counting by my 16s. And then 4 would make 64. So the function is, in order to get the total weight, you take the amount of milk, or the amount of, milk, I believe is M, and multiply each of these by 16. So 16 times M. Okay, and then it says to graph it. So we need to choose something appropriate on the y-axis scale. And remember, the x-axis is our milk. And I believe the milk is in gallons. And the W is weight in ounces. Okay, so let's choose an appropriate scale. We need to get all the way up to 64. So how can we get up to 64 with 8 lines? I believe 64 divides evenly by 8, and it would be 8. So let's just count by 8s. 8, 16, 24, 32, 40, 48, 56, and 64. Okay, so at 0, we're going to plot a dot at 0. 0 milk, 0 weight. At 1, you have 16. At 2, you have 32. At 3, you have 48. At 4, 64. So let's talk about whether I can draw a line connecting these. If I only make half a gallon of milk, if it was somewhere in between here, would that make 8 ounces of cheese? If I did like an in-between amount, it would. You don't just make milk by the 1 gallon, make cheese. You could make partial amounts. So actually it does make sense here to connect the points and to put an arrow at the end, because if I make a partial amount of a gallon of milk, it will make a partial amount of ounces. So this would be continuous. All right, let's look at now each wheel of cheese that he sells costs $9. So, and for some reason it did not copy the table down, so we're going to have to make a quick table right here. That's okay. So now it wants us to use It doesn't say. We're going to use N and A because N actually represents the number of wheels sold. So we'll put wheels sold, and that's N, number of wheels sold. And then our Y is A, which is amount, because that's going to be the money, the dollars. So this is going to be A for amount. Oops, sorry, couldn't see that. Dollars for the amount. Okay, so if each wheel of cheddar cheese costs $9, then that means the number, if the number was 0, I would be making $0. If the number was 1, if I made 1 wheel, then it would cost $9. 2 wheels cost $18. 3 wheels cost $27. 4 wheels, we'll just go to 4, cost $36, because all I'm doing is multiplying it by 9, because that's what it tells us. So our function then would be to get the total amount, you take 9 and multiply it by the number of wheels. So that is our function, or our equation. Now let's go graph it. We need to choose an appropriate scale on the y-axis, which it looks like our numbers go from 0 to 36. So I think we can count by 6s. Let's try 6s. 6, 12, 18, 24, 30, 36 is really the highest we need to go to. So at 0 wheels sold, we make $0. At 1 wheel sold, we make $9. At 2 wheels sold, 18. 3 is 27. 4 is 36. And then let's talk about whether it's continuous or discrete. If I connect these lines, that means I'm going to sell a part of a wheel of cheese. So I don't believe you can take a fractional amount and sell it. So it would not make sense to connect this, because I'm not going to sell 3 1/3 wheels of cheese. So I am not going to connect these. So we're only selling them in individual wheels. So therefore it is a discrete graph. Okay, let's look at the back. Just a couple of quick situations just to determine whether it's continuous or discrete. So the amount of water in a wading pool in gallons depends on the amount of minutes it takes to fill. So if I have something that's putting water out, this is a terrible drawing, but the amount of water that's in the wading pool depends on the time in minutes. So if I cut off a minute, can I cut it off in the middle of a minute? Yes, you can. So this one would be a continuously filling bucket or wading pool. So this would be continuous because it can have a partial amount. You can stop it. You don't have to just stop it at 1 gallon and then all of a sudden you turn it back on and now it's 2 gallons. You can have in-between amounts. So that is going to be connected, continuous. What about B? The cost of baseball tickets depends on the number of tickets bought. So can you buy half a baseball ticket? Or can you buy like 2 2/3 baseball tickets? You cannot. These are only going to be sold in individual amounts, so our graph would be discrete. All right, and then the last section is just a real quick review of how to graph. And we did this earlier, but what you need to do if you have an equation to be able to graph it is make a really quick X and Y table. Choose some X values that you can plug in. I said earlier I usually pick -2 through +2, but I'm also aware that I'm going to be taking half times a number. So if I take odd numbers, it's going to be a real ugly decimal, and I like to try to avoid graphing little decimal amounts. So I'm going to choose even numbers because I'm going to be multiplying by halves. So I'm going to choose a -2, 0, +2, and +4, just to see if they happen to lie on the graph. Once you choose your X values, go ahead and plug them in. So -2 is X, half of -2 is -1, +2 is 1. Half of 0 is just 0, so +2 is just going to be 2. Half of 2 is 1, +2 is 3. and then plug in 4 for x. Half of 4 is 2 plus 2, which is 4. And let's go graph these points and see where it's going to be on our graph. -2, 1, because these are your ordered pairs now. 0, 2, 2, 3, 4, 4, and there is your continuous graph, because these functions aren't specific situations, so we're just going to assume they have arrows on both ends and they're continuous. Okay, let's try the next one. Make a real quick table of values. I usually again, pick -2 through +2, but again, I notice here I'm going to be dividing each x value by 2, so I don't want weird decimal numbers. So I'm going to choose the same ones I chose earlier because they're even numbers, so they'll be nicely divisible. So we're going to fill in x with our first x value that I chose. So -2 divided by 2 is -1, plus 3 is 2. Use your calculator if you're not sure. 0 divided by anything is 0. Plus 3 would just be 3. 2 divided by 2 is 1. Plus 3 is 4. And then 4 divided by 2 is 2. Plus 3 is 5. So let's go graph these. -2, 2 is here. 0, 3 is up here. 2, 4, 4, 5. Go ahead and draw a line through with arrows on each end, showing that it is a continuous graph. All right, and then the last one, make a quick table of x and y values. Choose your x values. I'm not dividing by anything that's kind of a weird decimal, so I'm going to actually choose -2, -1, 0, 1, and 2. I like to choose a 0 and a couple of negatives and a couple of positives on either side, just to see where it lies on this graph. So now let's plug it in. -2 times -3. -2 times -3 is +6. Plus 2 is 8. I can already tell that was a bad choice because -2, 8 is not going to fit on my graph. It's going to be somewhere up here a little too far. So, but that's okay because we wouldn't have known to pick that unless we tried it. -1. Let's plug in -1. -1 times -3 is +3. Plus 2 is 5. I think that one will fit on this particular graph. -1, 5, barely. It's right there. All right, let's plug in 0. 0 times anything is 0. Plus 2 would just be 2. That one goes nicely on the graph. Let's plug in 1. 1 times -3 is -3. Plus 2 is -1. That one also goes nicely on the graph. And then 2 times -3 is -6. Plus 2 is -4. So when you go plot that one also goes nicely on the graph. So we were only off by 1, and it's okay. I mean, you don't know unless you try it. Try to pick some numbers and see what works.